Hello and welcome. In this video we will walk through the OSI model, the Open System Interconnection model. The OSI is created by the ISO, International Organization for Standardization, and is built on 7 layers, starting from the application, the presentation, session, transport, network, and data link, and ending with the physical layer, which is the bottom layer. So let's define what is the application layer. Okay, first of all, the application layer is everything that the user interacts with, like web browsers, for instance. And in the application layer, the data is generated, right? If you request open web browser and request say some data from a web server on the internet, that's the application, and also defines the authentication. Okay, sometimes if you want to log into some web browser or some site, it requires a login. Okay, so authentication is also defined in the application layer. The 6th layer, which is the presentation layer, it defines the data formatting. Okay, how the data is formatted. For example, is it JPEG? Okay, JPEG. Okay, or PNG if it's pictures. PNG, or it could be XML data formatting, or HTTP formatting. And also the presentation defines the encryption. The encryption is the process of rendering data unreadable to secure the data. We'll talk about the encryption later in the series. The 5th layer of the OSI model is a session layer. In this, the session layer defines how establishes the connection, start and end the sessions. Okay, and the layer 4 is the transport layer, which defines the data delivery, how data is delivered from one end to the other end, and also defines either using a TCP, which is a reliable protocol, connection oriented, or a UDP protocol, which is connectionless protocol. Defines also port numbers. Port numbers are to allow the computers to distinguish between services. For instance, if we are using HTTP, we are going to use port 80, and that's how to distinguish between what kind of service that we are using. Is it email, SMTP, HTTP, or HTTPS, or so on. And also it uses sequencing. Sequencing actually to resemble the data at the receiver host, and also to detect if there are errors and resend data if we are using the TCP right here, if we are using the reliable protocol, which is a TCP. Moving down to the network layer. Network layer actually is the 3rd layer of the OSI model and defines the logical addressing. The logical addressing are the IPv4 or IPv6 addresses that are used to route traffic from one destination, from one source to a destination. Also the routing. The routing is a process of forwarding packets from one host to another, and also path selection. And usually routers perform those this stuff that we are talking about, like routing, path selection, and stuff like that. The routers operate in layer 3 of the OSI model. Routers. Okay. Moving down one layer, we have the data link layer. The data link layer defines how the local network host delivery in the local area network or LAN, okay, and also defines the physical addresses, which are the MAC addresses that are burned in network cards, and they are 48 bits in binary. And the last layer, which is the bottom layer of the OSI, is the physical layer. The physical layer defines the bits, defines also how the electrical signals are transmitted over the medium or the wire. So think of the OSI model as a blueprint or a plan, okay, that helps break down the network into small pieces. And by breaking down the network into small pieces, we get some benefits actually. The first thing is a less complexity by breaking down the network into small chunks or small pieces, okay? The second benefit is the standard interfaces. The standard interfaces definition between each layer allow multiple vendors to create products that fit particular rule with all the benefits of an open competition. For example, you can actually by breaking down the network into small pieces, one company could focus, or one manufacturer could focus on the data link layer. For example, make net cards, right? Network cards. Okay, and allows other vendors to focus on the application by making some programs like email programs, database programs that operate in the data in the application layer, and they kind of work together according to the OSI model. The third benefit, which is easier to learn, okay, breaking down the network into small pieces, it's easy to learn and know actually each layer, how each layer, you know, how the data is working and defined in each layer as we walk through the application to the physical layer, and each layer defines some protocols and rules. Okay, so the fourth is easier to develop. Okay, reduced complexity allows easier programs, change faster, and product development. The multi-vendor on interoperability also, which, like as we mentioned, different vendors, they can focus on some layers, okay, and they, as we mentioned earlier, some programmers, they can make programs, okay, and others, they can make network cards, and all they kind of work together. Let's say we have a network card from Cisco, for example, okay, from Cisco, and the motherboard probably from Gigabyte, right? From Gigabyte, and they kind of interoperate and work together. The last benefit is modular engineering. One vendor can write software that implements higher layers, for example, web browsers, and the vendor can write software that implements the lower layers, for example, Microsoft built-in TCP IP software. Okay, so let's see how the data transmission from one host to another, or what's called peer-to-peer, and we'll see also how the data is encapsulated in the OSI model, and also how the data is decapsulated when it arrives to the destination. we have a user using a web browser, let's say Firefox in this case. Okay, he wants to reach this server. So the first thing that happens actually is the user here types, like for example, google.com, right, on his web browser. Google.com. Okay, and the first thing that happens is there is what is called a DNS, which stands for domain name system. Domain name system is responsible for translating host names like google.com to an IP address. Let's say the Google server address is 100 dot let's say .1 and .1. Okay, and the local host has the IP address, let's say 10.1.1.1. Okay, because computers doesn't know host names. Computers talk in binary, in bits or electrical signals, either zeros or ones. Either there is electricity in the wire or there is nothing, which is zero. So after the DNS resolve the host name to the IP address, the application, which is the Firefox in this case, generate the data and may also have some authentication or some kind of login. This also happens in the application. So we have the data in the application layer. We have data here, right? I'm going to type D. After the data is generated, then there is it goes down to the presentation layer. Okay, here we have the data, and then it goes down, and in the presentation layer the data is formatted. What kind of format? Is going to be the requested web page. There are images with JPEG, PNG, or XML, or HTML, or whatever kind of data. So the presentation adds a layer 6 header. Okay, I'm going to type the L6 for layer 6 header. Okay, then the data, okay, which is a D, layer 6 header, L6, and the session layer, which is L5. Okay, this is what's called the encapsulation. Okay, then it goes to the very important layer, which is the transport layer. Okay, data and all the other information related to the upper layers. So we have the data, we have L6 and 5, and then the transport layer adds a layer 4 header. Okay, and in layer 4 header we have a destination port number, and source port number. We have either what kind of protocol is going to use, either TCP or UDP. Since we are requesting HTTP, then it will use the TCP, which is the reliable protocol, right? And also some sequence numbers and acknowledgement. Then the all this PDU or protocol data unit, it goes down to the network layer, the data. Okay, layer 6. Okay, I'm going to type 6, 5, layer 4 header, and then the network layer adds a layer 3 header. And in layer 3 header we are talking about IP addressing, right? are talking about IP, and we are talking about a routing. Okay, the layer 3 header includes the source and the destination IP address. Okay, as we go down here, we have a layer 2 PTU, which includes the data, layer 6, layer 5 header, layer 4 header, okay, and layer 3 header, and then the data link adds layer 2 header, right? And in layer 2, we are talking about source and destination MAC address. And also it adds a trailer, which is FCS. The FCS stands for Frame Check Sequence, which check if there are errors in the frame. Okay. By the way, in the PGU, okay, the PGU here in the data link layer is called a frame. Okay, frame. Here in the network layer, it's called a packet. Okay, packet. And in the transport layer, it's called a segment. Segment. Okay, segment. So as the data is encapsulated with a layer 2 header and the trailer, which is the frame check sequence to check if there are errors, okay, then it goes to the physical layer right here. So in the physical layer, what happens is all this data is converted into bits, into binary bits, zeros and ones, right? Say 1, 1, 1, 1, 1, 0, 0, 0, 0, 0, okay? And it goes as electrical signals to the switch, okay? Let's say that this host is connected directly to a switch, okay? The switch then forward the frame in this case to a router. What really happens here, this host will check, okay, will check if the remote server is directly connected or reside on the same network. So what it will do, it will compare, let's say, okay, we said that we have the 10.1.1.1 and with the default mask of 255, 255, 255, and 0, right? And 0. So to know, for this host to know if the remote server is located on the same network or not, it will check the what's called the subnet mask, the default subnet mask. Okay, the default subnet mask for the 10.1.1.1 is 255.0.0.0. Okay, but let's say we do some subnetting and we have the mask of 255.255.255.255. So the computer check if the server has the 10. Okay, if you see like 255, which means check this one needs to match. Okay, the first thing it will look at this octet right here. Okay, so the first thing, it will compare the 10 to 100, which are not the same. Then automatically this host right here will know that the remote server is not connected on the same LAN. So what it will do, it will send an ARP protocol. It will send an ARP protocol. And the ARP protocol stands for Address Resolution Protocol, that translates IP addresses to MAC addresses, right? So it will broadcast. It's like saying, hi everybody on the local network. Let's say this is the local LAN. Hi everybody who has this IP address, I need his MAC. In this case, since the remote server is located on a different network, then it will add for the MAC address of the router. So it will send a broadcast to all the hosts that are connected to this switch right here, including the router. Everybody will drop the frame because it's not intended for them. So the router will check and sees its destination IP. Then it will respond with the MAC address of the router. Okay, so let's say a router respond to the host telling him that here's my MAC address, for example. Let's say 0000. Okay, and the MAC address is written in decimal. Let's say 11111 and 2222. So what the router does, okay, check the packet and compare it to its routing table. There is a routing table in memory of the router, okay, and sees that somehow the neighbor router is connected somehow to this network. So it will forward the packet to the next hop router. When this router gets it, actually, it will ask for the web server, checking for its MAC address. Then it will send him the bits, okay, to the physical layer. What's happened right here is as the data it goes to the data link layer. Okay, the data link layer actually strips out the layer 2 header and the trailer. Okay, so it will check, it will see that the data is intended for its MAC address, right, as the destination MAC, and it will strip the layer 2 header and the layer and the trailer, the FS trailer. Then the data is moved to network layer. The network layer will strip the layer 3 header that includes the source and destination IP. After the host checks that the data is intended for him, because it will seize its IP address as the destination. Then the data goes up to the transport layer. The transport layer actually strips out the layer 4 header, okay? Then the data is forwarded to the session layer. The session layer actually strips out layer 5, and the presentation layer strips out to the layer 6. Then the data appears on the server as a request, okay? Then the server will see that this user right here is requesting a web page from Google, right? So the same process will happen again. So this computer will do the same, okay? Will encapsulate the data and encapsulate the presentation layer, adds the presentation layer header, the session layer header, and this process is called, as we demonstrate here, it is called the encapsulation. And when the data arrives at this side, okay, it will start stripping out, okay, layer by layer headers till the data it arrives to this host right here. I hope this has been informative for you, and I would like to thank you for viewing.